Hello? 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 Can you hear me? Alright, boys. This is it. This is the moment we have all been waiting for. Can you still hear me? Good. Can you still hear me? Good. Aw, yeah. Alright. Let's send the stream to the boys. Why don't we? Come on now. Your channel attracted 1 new subscriber. Nice work. Shut up. You dummy. Alrighty. What am I doing? Bro, where is the freaking live stream? New videos, live stream. Hold up, I guess I gotta find it on here. No. No. No, stop. There we go. Alright, what am I doing? YouTube. Hold me now. I'm 6 feet on the ground and I'm singing. Oh yeah, baby. Alrighty. Booyah, baby. Alright. Oh yeah. Share that bad boy. Hop on. Let's spice it up. Let's spice it up. Let's invite everybody. Boom. Alright, everybody in Discord is invited. Okay, what is next? What is next? Who knows? Let me call Vard. Vardy party. Just to make sure he knows. Make sure he knows. Come on, Vard. You gotta answer. Please answer. Is that too loud?
Gideon, brother.
Yo, Vard. Are you gonna hop on the live stream? Practice flashcards?
Are you on the live stream?
Yeah, dude, I'm on right now.
Yeah, dude, send me a link.
Yeah, I just did.
Alright.
Alright. Hop on, brother.
Alright.
Alright. I'll see you there.
See you there.
Bye. What? Okay. That's what's up. Vard's joining the gang. Oh yeah. Boom. This is all my FFmpeg stuff, dude. I'm going hard. Going hard on this stuff. But today we're not doing FFmpeg. Today we're doing flashcards. Well, I mean today I was doing FFmpeg, but I need to do flashcards. Dude. Tell me a wish, baby girl. I want to hear you. Snake those hips. Throw them side to side. I want to see them drop. I want to see it in your eyes. Alright, is anybody there? Tell me someone's there. Come on now. There's gotta be someone. Oh wait, no, I gotta send it to King. I gotta lock in. Holy hold up. Hold up. Where's Kingy Wingy? King. Hop on. Hop on, baby girl. Yo, Corey White is here. What? Let's go. About to go crazy doing these flashcards. You know what I'm saying? Alright, let's get into it. Corey, you'll just get the extra studying. Everybody else is missing out. Alright. Simple squamous cells of the thin descending loop are permeable to blank, but impermeable to blank. Hold up. Alright, Corey. So what you gotta do is you gotta write in the chat, you gotta write down your answer before I do. Well, I mean, it can be after me, but you gotta write down your answer. And if everybody does that, then we'll get the answer correct, is the goal. Kangy Wangy is here. Hi, Kang. Kang. How do you... Oh, your name is right there. Yeah. Hi, Kang. Alright, what's the answer? What's the answer, Kang? I want to hear you. I want to see you type it. Water, salt. Yeah, so water and then solute. So pretty much salt, but some other ions too. Solute. I won't be able to answer. King, why won't you be able to answer? Or solutes. Just listening to. Okay. Okay, King. I still love you. Alright, yeah. So the simple squamous cells of the thin descending loop are permeable to water and impermeable to solutes. Perfect. Alright, the ascending limb of the loop of Henle is permeable to blank, so it's the exact opposite. So it is permeable to solutes, and it's impermeable to water, because it's trying to dilute the water, so it doesn't want to push out water, it wants to retain water in the ascending limb. Because the ascending limb is thick. It's a thick boy. It's got simple cuboidal instead of simple simple squamous. Let's go. Alright, what is the role of the loop of Henle? I already forgot this one. Oh wait, I remember some of it. What is the role of the loop of Henle? Right. Yeah, so create osmotic gradient and dilute urine. So it creates the osmotic gradient. Do you remember the little graph that she did? How can I pull that up? I don't think there's an easy way for me to pull that up. Hold up, wait a minute. Let's go to this. Yeah. Yeah, right here. Okay. So the nephron makes pushes out sodium, so it creates the gradient. And then something, I think the next question is going to be what does this thing do to move the sodium over here, over to this side. Anyways, we'll get to that. Let's go back to here. Okay, so create osmotic gradient and dilute urine. Create medullary, dang it. All right, create medullary osmotic gradient and produce urine. Produce dilute urine. There we go. All right, what is the role of the vasa recta? What is the role of the vasa recta? All right, so this, I want to see you guys type it out. I see that we have 3 viewers currently. I want to see all 3 of you guys. Is Vard there? Well, I guess if King is on, then he doesn't have to type it out because he said he can't. Uh-oh. There we go. Anyways, the role of the vasa recta is to maintain the osmotic pressure of the, not gonna lie, I don't know what the vasa recta does. Alright, so the vasa recta, yeah, let me pull up this picture again. So the vasa recta is do you remember the blood capillaries that run side to side right here? Here, let me look up a picture. Where's a good picture? I don't know, something like this. Okay, so this is the vasa recta right here. The white and red capillaries that are running this way. So it's pushing water to the left. So it's pushing water and solutes to the left to maintain the osmotic gradient because it's pushing like salt and stuff over on this side. Because it's being pushed out over here because salt is permeable, or solutes are permeable on this side. So it's drawing some of that solute over to this side to maintain the gradient on both sides. You know what I'm saying? Alright, so let's go back to here. Maintain the osmotic pressure of the, maintain the medullary. Because it's dipping into the medulla. Okay, so maintain the medullary osmotic pressure of the, I'm just going to put medullary osmotic pressure. Ah, dang it, not pressure, gradient. Maintain the gradient. I'm so dumb. Alright. Okay, aldosterone is stimulated by an increase or decrease in what ions? Okay, Spencer, I want to hear you say which ion when high stimulates aldosterone. And Corey, I want you to tell me which ion when low stimulates aldosterone. So aldosterone is stimulated by an increase in potassium, K+, and it is stimulated when there's a decrease in sodium? Yeah, potassium when high stimulates aldosterone. You got it, Spencer. Let's go. Corey, no. You are correct. So renin does eventually stimulate aldosterone, but we're talking about ions. If we were talking about shoot, what is it called? What is renin? A molecule? I don't know. Anyways, Corey, you're not dumb. You got the answer right, pretty much. Okay, so potassium, when high, stimulates aldosterone, and sodium, when low, stimulates aldosterone. Boom. Low sodium, high potassium. Let's go. Okay, what is the role of the vasa recta? All right, we just learned it, Spencer. So what is the role of the vasa recta? Corey, you can answer too. The whole point of this is just to type out your answers. And if you get it wrong, it's fine. And if you get it right, it's even better. Alright, so the role of the vasa recta is to maintain the medullary osmotic gradient. Alright, so what did you guys put? Maintain osmotic gradient. Let's go. Let's go, Spencer. Heck yeah. Let's see. Is there no way for me to like that? I guess I'll just put you guys in timeout for a minute as a reward. There we go. Delete it? No, I didn't delete it. What the heck? Why did it do that? Hopefully it comes back in 1 minute. That's crazy. Can I restore it? How do I restore this crap? I don't know. Sorry. I didn't mean to delete it. Alright. Okay, what does aldosterone increase in the basolateral membrane? Yo, VJ. Who's VJ? What's up, VJ? Hi, VJ. No. I'm sorry, Spencer. I deleted all your hard work. Okay, what does aldosterone increase in the basolateral membrane? Okay, so we gotta think, what is the main purpose, like, what is the basic function of aldosterone? Can someone tell me the basic function of aldosterone? Oh yeah, Vard Jensen. Of course it's VJ. I'm just not very good at stuff. Yes! Corey got it right. Spencer also got it right, but Corey got it first, and that's what matters. Just kidding. Spencer, you're all right. You did all right. Corey's just... Okay. Sodium. Where's the freaking... Yeah, there we go. Potassium. Pump. Yeah, let's go. So it stimulates the production of sodium potassium pump, and that causes sodium to go out of the cell into the blood capillary. Yeah, you guys are. You're both correct. And then can we get a W? Can we get W's in the chat? Let's get it. All right. So, the sodium potassium pump pumps sodium out of the cell into the blood vessel or the blood capillary, and that causes a osmotic gradient to be produced. So more sodium wants to come into the cell because it becomes hypotonic. You right? You guys following? So since it's pumping sodium out of the cell, it causes the cell to become hypotonic, which draws more sodium into the cell through the SGLT1 transporter protein. And that stands for sodium glucose transporter. Booyah. All right, the simple squamous cell of the thin descending loop are permeable to what? Vard Jensen, since you weren't here during the first part, I want to hear you. I want to hear what you have to say. What is the thin descending loop permeable to? Thin descending limb, I should say. That should be limb. Water, baby. Spencer got that thing. Yeah, because Vard, you remember your little mnemonic device, the waterfall? So when stuff is falling down the descending loop, when stuff is falling down the descending loop, it's water that's being pushed out. Yeah, I like where this is going. Let's go. All right, the ascending limb of the loop of Henle is permeable, so it's just the opposite. Waterfall, baby. That's right. So in the ascending limb of the loop of Henle, it is permeable to solutes and impermeable to water. Let's go. Okay, what is the role of the loop of Henle? So number 1, do you guys remember what it is? Vard, I'd like to see what your answer is. I'll give you 7 seconds. 1, 2, 3, 4, 5, 6, 7. All right. The role of the loop of Henle is to create the medullary osmotic gradient. And the second role of the loop of Henle is to produce dilute urine. Booyah, baby. All right, so the role of the loop of Henle is to create medullary osmotic gradient and to produce dilute urine. Right? Right. All right, we got it. All right, what does antidiuretic hormone, ADH, increase in the luminal membrane? All right. I want you guys to race to see who can get this answer first. What does ADH produce in the luminal side of the tubule? Yeah. Let's hear it, Spencer. ADH does not produce sodium, Spencer. You silly Billy. Because what does ADH stand for? It stands for antidiuretic hormone. So it means so against peeing hormone. So ADH is dealing with water, not sodium. Aquaporins! Let's go, Corey. All right. Yes, so aquaporins are increased in the luminal membrane. Heck yeah. All right. In dehydration and overhydration, what would the levels of So this is worded a little weird, but ADH release is blank with dehydration. So when you're dehydrated, would your ADH levels be high or low? Like, would you try and compensate for that by releasing a lot of ADH or decreasing your ADH release? Let's hear it. And then I'd like the answer for overhydration too. Increase with dehydration and decrease with overhydration. Let's go, Spencer. Let's go. Yeah, high, low. Let's go, VJ or Jensen. All right, in dehydration and overhydration, what would the levels of? Okay, so it's basically the same exact question. Okay, aldosterone release is blank with dehydration. And what is it for overhydration? Let's go, Vord. Hold up. I'm just going to spam this for a second. There we go. Opposite. Explain yourself, Spencer. Just kidding. You don't have to explain yourself. But I want you to really think about it. All right. What is the main purpose of aldosterone and the main purpose of ADH? They're on the same side. They're synergistic hormones. Okay, so aldosterone and ADH are synergistic hormones. So if you're dehydrated, then you want to increase your aldosterone release. And I like the dab. And then when you're overhydrated, you want to decrease. So lower. Increase then decrease as well. Let's go, Spencer. Okay, when filtrate reaches the medullary collecting duct, only blank of the filtrate remains. All right. So it wants a percentage value. So when filtrate reaches the medullary collecting duct, only blank percentage of the filtrate remains. So it is like filtering everything out. It's reabsorbing crap. Yeah, Spencer got that thing. 1%, baby. 1%, Vard. Let's go. All right, under the following conditions, report the levels of ADH and subsequent urine osmolarity and flow rate. Under the following conditions. Okay, so this is the graph talking about stuff. Let me just show you. What? Oh, never mind. Didn't work for some reason. We'll get to it again at some point. All right, aldosterone is stimulated by an increase or decrease in what ions? Okay, so it is stimulated by an increase in and decrease in. Spencer, go to find the emojis. If you look at your chat, I mean, it should be this. I don't know if you have this, but then all the emojis are right here. You know what I'm saying? Yeah, let's go, Spence. Spence star. All right, what's next? Okay, so an increase in potassium, baby. Yeah, decrease sodium. Let's go. Increase potassium. Yeah, so low sodium, high potassium. All right, what is the role of vasorecta? Maintain Medullary osmotic gradient. Maintain medullary osmotic gradient. And that's it, I think. Booyah. Booyah, baby. Alright, you guys get that? Hopefully. Hopefully you did. Not osmotic pressure. Osmotic gradient. I said pressure last time too, so if I confused you, Vard, I'm so sorry. But it's the gradient. You know what I'm saying? Alright. Where are fluids in the body absorbed? Alright, you guys, I want to hear it from you guys. Where are fluids in the body absorbed? Yes, sir. Bard, you're such a good boy. I mean, man. You're such a good man. Let's see. Why can't I reward you? There should be like a reward function somehow. This is lame. Timestamps. Oh, that's kind of cool. Okay. GI tract, let's go, Vard. So, yeah, the gastrointestinal intestinal tract. So the GI tract. Yeah, Vard. As your reward, you're getting put in timeout. Spencer wants you put in timeout. It always freaking why does it delete it? I don't want it to delete it. I'm just putting you in timeout. Alright. Alright, where are excess? Sorry about that. There we go. Alright, where are excess fluids and electrolytes lost? Oh, shoot. Sorry, I forgot something. I'll be back. Oh yeah, party is back, and so am I. Guess who's back? Back again. Shady's back. Tell a friend. What a G, dude. Howdy. Howdy to you. Hey, brother. Alright. Karina is such a G, dude. She brought this back. I left it at her place. Oopsies. And, yeah, so can we get some W Karinas in the chat? W Karinas in the chat. Slim Shady, let's go. Put him back in timeout. I like it. I think I will. I think Spencer needs a little timeout time too. I think he wants to go spend some time with Vard in timeout. There we go. Alright. Alright, where are excess fluids and electrolytes lost? W Karina. Let's go, Spencer. Alright, urine. Urine sweet. It's supposed to be sweat. Let me change that real quick. Alright, urine, sweat. Nope. There we go. There we go, baby. Sorry, I keep on moving the mic. Just trying to get a good angle. You know what I'm saying? Alright. What does aldosterone increase in the basolateral membrane? Corey got this right last time. Sodium potassium pump. Let's go, Spencer. Sium pump, baby. Pump it. You know what I'm saying? Alright, name the 6 functions of water. Oh yeah. Hold up. Give me just 1 second. Vard, you're on the wrong one, buddy. Oh, well. Yeah, you're right. That's what stimulates aldosterone. But we're talking about what does aldosterone produce? So if low sodium and high potassium was the first step and aldosterone release was the second step, then sodium potassium pump production would be the third step. So you're at step 1, but we're talking about step 3. Waste removal. Actually, let me sync this baby up. Let's sync this puppy. Where is that bad boy? Shoot. Yeah. So the acronym, here, let me type out the acronym. Sunflowers like tulips. Tulips. 'Cause huz thick. That's the acronym. Nah, dude. You made the mnemonic device, Vard. You're the one. You're the one that did it. Alright. But I accidentally lost it. We'll get back to it, though. Next time we do it, we'll get back to it. Hold up. I need to sync this real quick. You know what I'm saying? No. I need to stop saying that. You know what I'm saying? Alright, synchronize that bad boy. Syncing my flashcard, so now it will be the same on my computer. Not the huzz. That's right. We talk about the huzz in this chat. Alright, let's go to cards. Let's reset that bad boy. I don't want to Yeah. Yeah, buddy. Alright, there we go. Because I edited it. Alright, the simple squamous cells. Alright, I'm just going to go through. Vard Jensen has goated mnemonic devices. W mnemonic devices, for real. Honestly, pop off, Vard. Thank you, brother. Psh, you guys are so nice to each other. I think I need to reward Vard by putting him in timeout. Alright. Solutes. And water. Alright, what is the role of the loop of Henle? Create osmotic medullary osmotic gradient, and to produce dilute urine. There we go. Alright, what is the role of the vasorecta? maintain medullary osmotic gradient. Aldosterone is stimulated by an increase. Okay, so sodium low, potassium high. There we go, baby. All right, what does aldosterone increase in the basolateral membrane? Sodium, potassium pump. All right, what does antidiuretic hormone ADH increase in the luminal membrane? Aquaporins. In dehydration and overhydration, what were the levels? So ADH release is high with dehydration and low with yeah, Vard, you like being put in timeout. In dehydration and overhydration, sorry, I'm just trying to get back to where we were because I reset the cards. In dehydration and overhydration, what would the levels of aldosterone release is? High and low during overhydration. All right, give me just 1 second. Where is Karina for real? No more, please. Vard, if you keep on being a good boy, I'm gonna have to keep putting you in timeout. Just kidding. Keep being a good boy, Vard. Alright, when filtrate reaches the medullary collecting duct, only 1% of the filtrate remains. Where are fluids in the body absorbed? The intestinal tract, GI tract. Okay, where are excess fluids and electrolytes lost? Urine and sweat. There we go. All right, here we go. Here we go, Vard. This is your opportunity to shine. Look at this bad boy. Sunflowers like tulips because huz thick. Those tulips, dude, they're thickies, dude. The sunflower is a young gent. And he likes them thick tulips. Alright, so S. Alright, I want you guys to type it out, actually. Type it out, Vardy Party, since you're the one that created it. I want to see it. Booyah. Yeah. You could say I have like a W streaming setup or something. I just got my stuff today. Solvent, lubricant, transport, cushion, hydrolysis, and temperature regulation. Let's go. Where is it? Solvent, lubrication, temp regulation, cushion, hydrolysis, transportation. Yeah, let's go, Karina. Let's get another W, Karina, in the chat. And let's show her our customs. Let's show her our customs by giving her. Let's do a W, Karina. Oh, I don't know how to spell Karina. Karina. W, Karina. And then let's give her the good old timeout as a reward. There we go. All right, solvent, lubricant, temp regulation, cushion, hydrolysis, and transportation. Let's go, baby. Oh yeah. W, Karina. Now get in timeout. That's right, Spencer. Spencer loves it. Loves timeout. Alright, the amount of water in the body depends on the amount of... I honestly forgot this one. I'm not sure. That's what I get for trying to... Did you mean to say too hard, Karina? You tried a little not too hard with that one. Put me in timeout. Alright. I'll give you a 5-minute timeout. Dude, Bard got that thing. Holy cow, Bard is on a roll. Oh yeah. Alright. Alright, Corey. I feel like that was a little too long, Spencer. Can I get you out of timeout? Should I just put you in timeout again? Alright. Who has the highest and the lowest amount of water percentage? Corey, I need you to answer this one. I need some... I first need who it is, so the first answer right here is who it is. And then the second is the percentage. Same with this one. So who it is and percentage. And I mean, anybody can answer, but Corey, I want you to answer first because I believe in you. Unless Vard gets it, because Vard is on a roll. Alright, let's hear it, Vard. If you have it. So first, it's newborns. And the percentage is 73%. So that's this. And then the lowest is morbidly. Can I be so for real with you, G Money? I don't know. It's okay, Corey. I also like G Money. It's pretty good. Pretty good name. Alright. Newborns, 73%, and morbidly obese. Morbidly obese. Yeah, Karina got that thing. Holy cow. Karina's about to pop off on you, Vard. Karina's about to overtake you. What do you think about that? Morbidly obese. Let's go. W, Karina, for real. I think Karina needs a little timeout to let the others settle in. Also, wait, Spencer, are you still in timeout? I'm sorry. Finally out of timeout. Let's go. W. Alright, list the three. Yeah, I just put her in timeout. Everyone is so big brained. Alright, list the 3 fluid compartments and the percentage of total body water in each. Alright, I want to hear you guys say it. I want to hear you guys all say it simultaneously. Well, I can't hear you, but I want to see you type it out simultaneously. I'm going to give you 6.5 seconds. 1, 2, 3, 4, 5, 6.5. Alright. I already forgot. Just kidding. Intracellular fluid is 62%. Yeah, I like that, Vard. I like it. Let's go, Spencer. Alright. Interstitial fluid is 30%. And plasma, so blood plasma, is 8%. Yeah, Spencer. Yeah. I like how you think, Spencer. You really get me going, Spencer. All right. The simple squamous cells of the thin descending loop are permeable to water and impermeable to solutes. All right. Give an example of each of the following solutes. Let's see. Who do I want to pick on? Vard. Give me 3 examples of ion/electrolyte solutes. And then Corey, I want 1 example of colloids. And Karina, I want 2 examples of non-electrolytes. Brinley Hawes, let's go. Yo, Brinley. As a first-time guest, we have to get you accustomed to our customs. So you're going into the timeout. All right. Sodium, potassium, and chloride. Yeah, chloride. Let's go, Spencer. Vard. Yeah. So sodium. Oops. Sodium, potassium, and chloride. Boom. And then Vard Jensen put proteins, but that was Corey White's job. But I'll still put proteins. And then the third one, Karina put nutrients. Nutrients/glucose, because glucose is a nutrient. Booyah, baby. All right, so the other ions are calcium, 2 positive, and bicarbonate. But we pretty much got that one. We got that, baby. All right. The ascending limb of the loop of Henle is permeable to solutes and impermeable to water. Wait, Brinley, are you out of time? Are you out of time out yet? Sorry, we gotta. It's tradition now. We have to. We have to put everybody in timeout. Okay, Brinley, I want you to tell me what the role of the loop of Henle is if you are out of timeout. I think Brinley might have left. I think since I put her in timeout, she just immediately left. I'm sorry, Brinley. That sucks. Okay, who else? Karina, tell me what the role of the loop of Henle is. Anybody can type it out, by the way, for any of these. Yeah, oh, Brinley Hawes is here. Let's go. All right, so that's the second one. So produce dilute urine. So what is the first one? So the first one is to create medullary osmotic gradient. Booyah, baby. Let's go, Karina. She got that crap. All right, what is the role of the vasa recta? All right, Brinley. Actually, no, let me pick on someone else. Who else hasn't gone in a long time? Is there anybody new here? It says that there's 4 concurrent viewers. So I'm not sure if anybody new is here. How about everybody? Everybody write down your answer for what the role is of the vasa recta. And make it snappy. All right, so the role of the vasa recta is to maintain the medullary. Let's go, Spenstar. Osmotic. Make sure you change that A to an O, Spencer. The osmotic gradient. Let's go. All right. In dehydration and overhydration, what would the levels of aldosterone release? Okay, so when you're dehydrated, you would release high or low aldosterone. So you'd release high aldosterone, and when you're overhydrated, you'd release low aldosterone. Let's go, baby. Same thing with ADH, because ADH and aldosterone are synergistic in a sense. I don't know. So let's see. No, Vard. No. I need to put you in timeout at least one more time before you go to bed. There we go. Okay. Good night, Vard. I love you. I'm sorry. I'm sorry we kept you up late. Alright. When filtrate reaches the medullary collecting duct, only 1% of filtrate remains. Alright. What does antidiuretic hormone increase in the luminal membrane? Put Brindley in timeout since what? Since what, Spencer? Oh shoot. Someone send me 100s. W. Alright, let's put Spencer. Let's put Spenstar in timeout for 24 hours. Just kidding. Let's put him in timeout for 1 minute. And let's get Brindley and go. Good old 10 seconds. Oh shoot. Brindley just caught. Aquaporins, baby. Love you, dog. I love you too, Vard. You're my soul angel. Alright, aldosterone. I hope you sleep well, Vard. I genuinely mean it. I'll visit you. Just kidding. Aldosterone is stimulated by an increase or decrease in what ions? So it's going to be an increase, it's going to be a decrease, so low sodium and high potassium. Gosh darn it. There we go. Hey there. Low sodium, high potassium. Let's go, baby. Alright, what does aldosterone increase in the basolateral membrane? Aldosterone increases... Oh, wait. Brindley, tell me what aldosterone increases in the basolateral membrane. If you're out of time yet. Timeout. Yeah, I only put you in for 10 seconds, so you're good. You're good. I think... We're going to ace the quiz tomorrow. For real, Spencer. Sodium potassium pump. Let's go. Sodium potassium pump. Let's go, Karina. You guys both deserve a good old timeout. You know what I'm saying? You guys are too good. Hold up. Let me see. There we go. Yeah, Brindley. Let's go. Alright. Where are fluids in the body absorbed? Okay, whoever is not in timeout, answer this one. I'll give you 5 seconds. Alright. Fluids in the body are absorbed in the gastrointestinal tract or the GI tract. Booyah, baby. Alright. Oh, I think I might have put my entire viewer base in timeout because I think I only have 3. Oops. Okay. Where are excess fluids and electrolytes lost? This would be urine and sweating. Or sweat. I think everyone in here was in timeout. Yeah. Oops. Dummy. Whatever, Karina. I think you deserve another time. That's only 10 seconds. Don't worry about it. Alright. Ooh, okay. Someone name all of these. Someone tell me all 6. All 6 functions of water. Sunflowers like tulips because huz thick. Solvent, obviously. Solvent. Lubricate. Lubricant, sorry. Lubricant. Tulips. Temp regulation. Cause. So C would be cushion. Cushion. And huz would be H. Hydrolysis. Yeah, let's go. And then transport. Let's go, Spenstar. Transportation. Too good. Alright, the amount of water in the body depends on the amount of... What is it? Someone type it out real quick. The amount of water in the body depends on the amount of adipose, baby. Pose that addy. Alright, give an example of each of the following solutes. Okay, so what were they? They were sodium, potassium. Yeah, Spencer got that thing. Sodium, potassium, chloride, calcium, 2 positive, and bicarbonate, HCO3 negative. 2 concurrent viewers. Dude, who left? Did Brindley leave? Come on, guys. Alright, then colloids is proteins. And then non-electrolytes is nutrients / glucose. Let's go, baby. Let's go, baby girl. Alright, who has the highest and lowest amount of water percentage? Highest is newborns. And their percent is 73%. And then lowest is morbidly obese. And they have 40% water. Alright, so newborns, 30% water. Morbidly obese, 40% water. Easy. Alright, list the 3 fluid compartments and the percentage of total body water in each. Okay, so you have intracellular. Let's go, Spencer. Newborn, 73%. Obese, 40%. Ah, yeah. Intracellular is 62%. Interstitial is 30%. And plasma is 8%. There we go, baby. I put everybody in timeout so many times. Alright, list the major extracellular and intracellular cations and anions. Okay, so extracellular cation. The extracellular cation is potassium. And the extracellular anion, oh shoot, no, not extracellular, no, potassium is intracellular. So sodium, and then the anion, is it chloride? I can't remember. And then the intracellular cation is potassium. And the extracellular anion, or intracellular anions, is proteins. Sodium, chloride, potassium, proteins. Let's go. Let's go, Karina. You clutched up. You helped me in a time of need. Alright, with a fluid compartment, the total number of blank must be equal to the total number of blank. Okay, so what it's talking about is it wants to keep Karina's in the chat. Let's go, Spencer. Oh, yeah. Alright, within a fluid compartment, the total number of positive charges must be equal to the total number of negative charges. Negative. Darn it. Positive, negative. Let's go. Alright, gain or loss of water in the body. Gain is what two things and what is the amount of them? Okay, so how do you gain liquids or gain water in the body? Karina is cracked for real. I think Karina is a little too cracked. I think she might need to be nerfed with a 1 minute timeout. Alright, Spencer, it's all on you. I gave you a 1 minute lead on Karina. Alright, so gain is what two things? So gain is food and water, which equal 2300 milliliters. And then cellular respiration. Cellular respiration is 200 milliliters. So the total is 2,500 milliliters. All right. Food and water, 2,300 milliliters. Cellular respiration, 200 milliliters. And the total is 250 milliliters. Beautiful. Okay, so what are the four things that you lose water from? Starting with the most abundant. I'll give you 3 seconds. Alright, so it is urine, excretion, just urine, which is 1,500 milliliters, skin, which is 600 milliliters, lungs, which is 300 milliliters. Yo, Spencer got that crap. And then, GI tract, which is 100 milliliters. There we go, baby. And the total is 2,500 milliliters. Because whatever you take in has to be what you put out. Okay, when more solute particles are added to one side of the container. Oh, kidney. Oh, shoot. Yeah, I totally said urine instead of kidney. That sucks. Okay. Karina, you're too good. Alright, when more solute particles are added to one side of a container with a selectively permeable membrane, which way will the water flow? So you'll become so it'll be hypertonic. Yeah. Flows to the hypertonic side. Let's go, Spencer. Alright. To the side of more solutes. Water is moving down its concentration gradient. Yeah, so the hypertonic side. Alright, what happens to a patient's red blood cells when the following with the following solutions? Okay, so if you were to inject a hypotonic solution, so like distilled water, if you were to inject distilled water straight into someone's vein, what would happen to the red blood cells? So hypotonic would cause the cells to lyse. Hypertonic would cause them to crenate. And isotonic would do nothing. Let's go, baby. Hypotonic, lyse. Hypertonic, crenate. Isotonic, nothing. Let's go, Spencer. W. Alright, what are the 4 primary mechanisms to regulate fluid homeostasis? I don't know this one. I'm going to need help with this one. Alright, what are the 4 primary mechanisms to regulate fluid homeostasis? Oh, right, I remember this one. Okay, ADH, thirst, aldosterone, and sympathetic stimulation. Let's go, baby. Yeah. So the 4 primary mechanisms to regulate fluid homeostasis are ADH, thirst, aldosterone, and sympathetic stimulation. We got that. Alright. Answer the following questions on antidiuretic hormone. Okay, what is the major stimulus? Yeah, Karina got that crap. Let's go, Karina. You're going in timeout. I think Spencer needs a little timeout too. Yo, thanks for joining the stream, Spenstar. Bye, Spency. I love you. Sleep well. Alright, what is the major stimulus? We're almost there. Gotta power through. What is the major stimulus? So, high osmolarity, right? Osmolarity. High osmolarity was the direct effect of the hormone. So increase aquaporins. And then what effect will this have on plasma volume? So it will increase plasma volume, and plasma osmolarity will decrease. And then what effect will this have on urine volume? It will decrease and increase the osmolarity. Increase osmolarity, increase aquaporins, high, low, low, high. Let's go, Karina. increased plasma osmolarity. Aquaporins in distal convoluted tubule. Dang it, I forgot that one. But we're good. We're good. All right, give an example of give an example of each of the following. Okay, ions: sodium, potassium, chloride, calcium, bicarbonates. All right, colloids, proteins, and then non-electrolytes would be nutrients, / glucose. Nice. All right, list 3 ways dehydration leads to an increased thirst. Okay, so number 1. So only say number 1. So this would be dry mouth stimulates the thirst center. All right, dry mouth and throat signals the hypothalamus thirst center through the glossopharyngeal nerve. Oh yeah. Yo, what's up? Don't you love my setup, dude? This thing is awesome. All right. Dry mouth stimulates thirst center. All right, list the major extracellular and intracellular cations and anions. Okay, so extracellular would be sodium. Anion would be chloride. Dang it. Intracellular would be potassium. And intracellular anion would be proteins. Nice. All right, within a fluid compartment, the total number of blank must be equal to the total number of blank. Okay, so the total number of, let's go Karina. Can we get some W Karina in the chat? Even though Karina's the only one. Let's go. All right. Within a fluid compartment, the total number of negative charge or positive charges, positive charges must be equal to the total number of negative charges. W Karina's in the chat. Let's go. All right. List 3 ways dehydration leads to increased thirst. So number 2, increased thirst. Increased plasma osmolarity. So increase plasma osmolarity. Increase plasma osmolarity. Is this the second one? I don't remember. Increase plasma osmolarity, or increased plasma osmolarity, creates the plasma osmoreceptors to stimulate the thirst center of the hypothalamus. Plasma osmoreceptors stimulate thirst center. Let's go. I basically got it. That's basically it. All right, list 3 ways dehydration leads to increased thirst. So the third one. So dry mouth, plasma osmoreceptors, and Low blood pressure. I mean, low blood volume. Yes, low blood volume. Low blood volume stimulates the thirst receptors in the hypothalamus thirst center. Thirst center. Ah, dang it! No, renin-angiotensin system. Dang it! Let me redo that one real quick. Okay, low blood pressure, which then causes the release of renin and angiotensin system. Right. Oh, dang, I put blood pressure. No, blood volume. Blood volume. I'm such a dummy. All right. Gain or loss of water in the body. Gain is what? Two things, and what is the amount of them together? So gain is food and water, which equal 2,300 milliliters. And then loss of water in the body. And then cellular respiration is 200 milliliters. So the total is 2,500 milliliters. Let's go. All right. Gain or loss of water in the body. Loss is what? Four things, and what is the amount of them together? So the first would be kidneys. Didn't forget this time, which is 1,500 milliliters. Skin is next with 600 milliliters. And then lungs is third with 300 milliliters. And GI tract is last with 100 milliliters. W, and then total is 250 milliliters. Let's go. All right, when more solute particles are added to one side of a container with a selectively permeable membrane, which way will the water move? Okay, so water moves, flows towards the hyper poop 100. Yeah, kidneys is 1,500, Karina. Get it right. Get it right. Hypertonic side. Alright. Okay, what happens to a patient's red blood cells with the following solutions? Okay, so hypotonic is lyse. Hypertonic is crenate. Isotonic is nothing. Alright, what enzyme is released from the kidney in response to decreased blood pressure? Renin. What enzyme converts angiotensin 1 to angiotensin 2? ACE. Angiotensin converting enzyme. Okay. What are two effects of angiotensin 2? Vasoconstrictor, and increase blood pressure. Okay, how does aldosterone cause more sodium to be absorbed in the kidneys? increase sodium, potassium pumps. And then as a result, what happens to blood volume and blood pressure? Increase. There we go. All right, renin, ACE, angiotensin converting enzyme, aldosterone. Oh, aldosterone. Dang it, I forgot that one. Okay, aldosterone, vasoconstriction, more sodium potassium pumps, increase. What are the 4 primary mechanisms to regulate fluid homeostasis? ADH. Nope. ADH. No. Aldosterone. Sympathetic stimulation. What is... Shoot, there's something in between ADH and aldosterone. ADH. I can't remember. Thirst. ADH, thirst, aldosterone. Okay. Hold up. ADH, thirst, aldosterone, and sympathetic stimulation. There we go. Okay. Answer the following questions on antidiuretic hormone. Was the major stimulus? Major stimulus is high osmolarity. High osmolarity. Was the direct effect of the hormone increase aquaporins? All right, what effect will this have on plasma volume? Increase and osmolarity. Oh wait, no. Okay, so up, down on osmolarity, and then urine volume will go down, and urine osmolarity will go up. W. Increase plasma osmolarity. Add aquaporins in distal convoluted tubule, and then up, down, down, up. Nice. List 4 ways dehydration leads to increased thirst. Number 3. So dry mouth, plasma osmoreceptors, dry mouth, plasma osmoreceptors, decreased blood volume. Decreased blood volume. Decreased blood volume. Cause, dang it, dude, I knew it. Yeah, low blood volume, and that is angiotensin. Oh wait, no, renin slash or dash angiotensin system. All right, list 3 ways dehydration leads to increased thirst. All right, let's think about this. List 3 ways dehydration leads to increased thirst. 3 ways. First, dry mouth. Dry mouth stimulates the hypothalamic thirst center. Yeah, dry mouth and throat. Dry mouth and throat signals the hypothalamus thirst center. Nice. All right, decrease in blood volume and blood pressure will lead to an increase in sympathetic nervous system. All right, decrease in blood volume and blood pressure will lead to an increase in sympathetic nervous system. This will result in up, afferent arterial constriction. Down, blood flow to the glomerulus. Down, urine loss. And up, renin release. Let's go. Alright, under the following conditions, report the levels of ADH and subsequent urine osmolarity and flow rate. Under the following conditions, report the levels of ADH and subsequent urine osmolarity and flow rate. Oh, this is the grid. Come on, man. Show it to me. Oh, no. No. Dang it. I guess it doesn't want to show it to me. Okay, list 3 ways dehydration leads to increased thirst. Number 2. Plasma osmoreceptors in signal the hypothalamus thirst center. Yeah, stimulate thirst center. There we go. All right. Below are listed the 4 examples of disturbances in water homeostasis indicate if there is an increase. Okay, so hypervolemia is an increase. It's isotonic. An example is IV solution. Hypovolemia is a decrease in volume. It is isotonic and it is bleeding out. That's an example. Overhydration is an increase in volume, decrease in osmolarity, drink too much water and not pee. Dehydration is a decrease in volume, an increase in osmolarity, and sweeting. Blood pressure decreases. Beautiful. Alright, what enzyme is released from the kidney in response to decreased blood pressure? What enzyme is released from the kidney in response to decreased blood pressure? Renin. Of course. What enzyme converts angiotensin 1 to angiotensin 2? ACE, obviously. What are the 2 effects of angiotensin 2? Aldosterone and vasoconstriction. How does aldosterone cause more sodium to be absorbed in the kidneys? Increase sodium potassium pump. And then as a result, what happens to blood volume and blood pressure? Increase. There we go. Alright, decrease in blood volume and blood pressure will lead to an increase in sympathetic nervous system. Alright, decrease in blood volume and blood pressure will lead to an increase in the sympathetic nervous system. This will result in up, afferent arterial constriction, down, blood flow to the glomerulus, down blood or urine loss, and up renin release. Nice. List 4 ways dehydration leads to increased thirst. Number 3. So this one is, why do I always forget this one? Okay, so it's dry mouth, plasma osmoreceptors, and dry mouth, plasma osmoreceptors, and low blood volume. Low blood volume, which really causes renin / angiotensin. Renin / angiotensin System. Nice. Alright, under the following conditions. Yeah, let's go. Alright, under the following conditions, report the levels of ADH and subsequent urine osmolarity and flow rate. Come on. It never shows it. Alright, under... Oh, is that it? I don't know. Anyways, we're done. Hallelujah, Karina. Oh my gosh, I'm tired. That was pretty fun though. I like the streaming setup. It gets me excited. It makes me be able to do this and then rub my hands together and you can see everything. You can see all of me. You ready? You can just zoom in. You can just zoom in on all of that, dude. And then I can go like this. Hey there, baby girl. How's it going? Yeah. Alright. Goodbye. Time to turn this puppy off.